Once again, you're welcome to our online lesson, Math Made Easy with PDY. It's a great privilege coming your way with another interesting topic for our discussion. Now, without wasting my time, you believe that in this our everyday life activity, you realize that things changes from one state to the other, and therefore, mathematically, when things change from one state to the other, then we say that the object or the item varies. And therefore, the topic we are going to consider for our lesson today is variations. Is variation. Now, what do we expect to learn under variation? So, variation is so broad, and therefore, our main lesson for today is going to be direct and indirect or inverse variations. By the end of the lesson, the objective is that you should be able to express direct variations in symbols, and then you should be able to express inverse variation in symbol form, and then you should be able to solve problems involving direct variations and then problems involving inverse variation. So this is our major objective for today, and it's my wish that by the end of the lesson you should be able to get this going. Since we have good background in solving equations, then it means variation is going to be an interesting topic for us to consider. So as I introduce the lesson, we are going to consider the topic variations. Variations. So someone may ask, what exactly is variations? Now, variation actually shows the relationship between two or more quantities in which a change in one quantity results in a change in another. It will interest you to know that when you were giving birth, due to external and then internal factors that actually took place with respect to your body, you changed from one state, which is from a baby to a teenager, and you keep on changing until the final day God calls you. And even with respect to the items you put on from one state to the other, when you were a baby and you were very small, you put on smaller clothes. But as the changes took place, it happens that your clothes changed from one state to the other. Your shoe size also changed from one state to the other, from a smaller state to a larger state, and it goes on and on and on. So in our daily life, we very often come across situations where two or more quantities, which are called variables. So anything that we actually use, we classify it as variable because it changes from one state to the other, and it's coming from the word varies. Varies. We come across two or more quantities called variables and are related so that when there is a change in one variable, there's a corresponding change in the other variables. Variation enables us to obtain a relationship between variables. So your feet size may cause a change in your shoe size. Your body size may cause a change in your clothes size, and so on and so forth. So let's take it that someone may be big enough, may like to reduce their weight, and hence when the weight is reduced through exercise and other means and it becomes small, the clothes size may change from either size 8 to size 7 or size 6, and so on and so forth. So in our discussion, there are some key terms that you'll be hearing. So square root of p, which symbolically you can write it as this, square of q, which is symbolically written as that, cube root of p, this is how symbolically you can write it, and then cube of q, symbolically this is how it is written. So these are some symbols you've already seen early on when you were writing equations and so on and so forth. So based on the concept we are going to consider today under variations, then it means that there's a need for you to refresh your memories on these key terms. So that is basically our discussion for today. Now, when it comes to variations, as I said, as there's a change in one quantity, it causes a change in another quantity. It makes us have different kinds of variations in life. So, considering variations, we have different kinds or types of variations. And they are put into groups like direct, indirect, or inverse. And then we have what we call joint and then partial. For the sake of time, I'm going to take the first two and then the last two be considered in our next lesson. Now, for direct variation, it is a type of variation for which as one quantity increases, automatically the other quantity also increases. So an increase in one variable causes an automatic increase in another variable. That is one thing about direct variation. So increase in one variable causes an automatic increase in other variables. It might be either one or more. Now, a specific example is that when there's an increase in fuel prices, automatically there's going to be a corresponding increase in the fare of transport. And I believe you've been observing that whenever they increase the price of fuel or gas, you realize that the transport fares actually does what? Increases. Can you give me another example whereby as one variable increases, the other also increase? So I've considered fuel price. Automatically there will be increase in fares of transport. Yes, can you give me another example, please?
An increase in gas may lead to an increase in um, meals.
Okay, so increase in fuel price also causes automatic increase in this time you are saying meals. So can we use another word for meals? Maybe you can consider
Foodstuffs.
foodstuffs. Yes, foodstuffs, because um as long as these foodstuffs needs to be transported, then it means that it will cause our foodstuffs to also increase. The selling of foodstuffs in the market will automatically also increase. So let's say we can also consider body size increase. So let's use body size. When you have your body size increase, then it means that you are going to have your clothes size also increase. That is direct variation. That is direct. Now, as I said, it is not only when you have an increase in one variable, then automatically increase in the other. There can also be a decrease. There can also be a decrease. So meaning that, so when there's a decrease in one quantity, there will also be a decrease in the other. So that is also direct. That is also direct variation. But we normally considers direct more of when it increases, but it can be the other way around also. When there's a decrease in one quantity, there will also be automatically decrease in the other. Please, are you all with me? Any questions so far on what I've explained with respect to um, direct variation?
No, please.
Okay, so now graphically, graphically, if we represent this data into a two-dimensional um, information, if we have our y-axis here and we have our x-axis there, you bear with me that as you move towards the right hand side of the x-axis, all the values increases in terms of x. As you move upwards, then the y values also increases because it goes into positive infinity, and then the x also goes into positive infinity here. So ideally, the graphical representation is that as x increases, automatically y also increases. So when you draw the graph of this, it will give you a positive gradient graph. So this is how the graph looks like when it comes to direct variation. So basically, that is how the graphical representation of direct variation is given. So there are other examples for which I wouldn't like to spend my time on just the example, but as we take work examples, it will cause you to understand it the more. When it comes to variation, symbolically, as I said, we use the word varies. And we use this alpha symbol to represent varies. So if A varies as B, then we have to write it as symbolically A varies as B. Or if X varies as B, directly as B, then we can say that X varies directly as B. This is how symbolically we represent the direct variation statement. That's how we represent it. Then now you can change the symbolic statement into an equation. Now, when you are changing the symbolic statement into an equation, then it means that you are going to make it a firm statement for which further investigations can be made on it for future references, so that in our next prediction, then that equation will have a constant of variation. So you'll be having a word constant of variation, or proportionality, constant of variation or proportionality. So constant of variation or proportionality will be introduced to your symbolic statement to make it an equation. And that constant of variation or proportionality makes it easy for future references. So in this case, whatever I've just said, there's a summary of it. So suppose a relationship exists between one variable and the other, so that an increase in one value of variable causes a corresponding increase in the value of another variable, or vice versa. As I said, when it decreases, this is called direct variation. Now, problems involving direct variations, normally we do use statements like P is directly proportional to I, or P varies directly with I, or P varies directly as I. And this is how symbolically we represent it. P varies as I. And hence, when you want to change this symbolic statement into an equation, then you are going to write it as P is equal to, then you introduce your constant of proportionality. For it, the symbol is K. Then you introduce your I. So P is equal to Ki. P is equal to Ki. And the constant of proportionality is actually introduced to make it easy for you um, predict future changes. As P changes, then I will automatically change based on its constant of proportionality. So that is basically how direct variations are written symbolically and how you change it into an equation. Any question so far before I take some work examples for us to work with it?
Yes, please.
All right. So let us take one question and then deal with it. So the first question I would like us to consider, write it down, please. Kindly write it down. Suppose y varies directly as x changes. If y is 6 when x is 36, find the value of constant of variation. Find the value of constant variation. Okay, so interestingly, this is a direct variation question. And if you look at it carefully, they've already even given you the future occurrence. If y is 6 when x is 36 in that state, find the constant of variation. So the way forward is to first consider writing your symbolic statement for the first information. Y varies directly as x changes. So let's say solution y varies as x changes directly. So that's how symbolically we can write it. Then for future references, we need to change this symbolic statement into an equation. And in doing so, that is when we introduce a constant of proportionality or variation. And therefore, that is going to give us y is equal to kx. Are we all okay from the symbolic state to an equation state?
Yes, please.
All right. So going further, now, if this is an equation for future references, then they give us a statement for the future reference. If y is 6 when x is 36, so we have been told that y is equal to 6 and x is equal to 36 in the future. We should use these two information to get the constant of variation value. And in this case, to do so, we've learned about how to substitute variables. So we can say that 6 will be equal to k multiplying 36. And in finding your k value, then you have to make k the subject. And therefore, we divide both sides by 36. So finally, k value will be what?
One
What?
out of 6.
1 out of 6. Very good. 1 out of 6. So it tells you that the constant of variation value is 1 out of 6. So ideally, if you want to write the equation finally, for which the question did not ask for it, the relationship between y and x based on this statement here is supposed to be y is equal to 1 out of 6 of x. 1 out of 6 of x. So the constant of variation is a 1 out of 6. So meaning that anytime you know your s value for future references, when you multiply by 1 out of 6, you automatically generate your y value. Or if you know your y value and you want to find your s value with 1 out of 6 as your constant of variation, you'll be able to find the other. So that is a relationship between y and x based on our question here. Can we go to another, please?
Yes, please.
All right. So kindly write this one also down. Can you, or maybe if I can take the next concept, then after which we'll do more work examples. Can I take the next concept so that we'll do more work examples
Please.
afterwards? Okay, so going to the next concept, then we are going to consider what we call the indirect or inverse variation. What do you think inverse refers to? Whereas direct variation, one quantity increases, automatically there's a cause or change in the other in terms of also increasing, or vice versa. When there's a decrease in the other, there's also a decrease in. But what about inverse? How would you explain the concept of inverse variation or proportion? I know you've treated these things some time ago. Yes, inverse proportion or inverse variation. How would you explain that concept? So that when we are done, we'll just do more work examples on them.
Sir,
Yes, please. I'm listening.
please, when something is inversely proportional to something, for example, y is inversely proportional to x, it will be y, then the sign, then 1 over x.
1 over x. So can you give maybe a real life situation as you are saying 1 over x becomes the inverse? But let's come to real life situation. What does it intend?
So as one is increasing, the other is decreasing.
Automatically. Thank you very much for that brilliant explanation. So inverse variation, as one quantity increases, there's the the other side of it, that is there's a corresponding decrease in the other quantity. That is what inverse variation is about. That is what the inverse variation is about. Can you give me an example in real life? As one quantity increases, the other rather decreases.
Please, I can use Nataraj pen and Big Pen. If the price of Nataraj pen increases, um the how do you call it?
Big pen.
Yeah. No. When the price of Nataraj increases, the sale for Nataraj will decrease, whilst the Big Pen will rather increase.
Oh, is that so? I have actually not experienced it, but maybe that's what we've experienced. As maybe these two pens, one is higher in price, and then it causes a corresponding decrease in the other. Is that what you're saying?
No, no, I'm saying that the one with the higher price will have
Yes.
a lower sale,
Oh, okay. We would
and the one
rather
with the
have a
lower
lower.
price will have a higher.
Oh, okay. All right. Let me also bring one idea also on board to remind you. Now, when it comes to, let's say, variables like speed and time, and then distance, speed, time, and distance, these three variables, you realize that the faster you run, the shorter time you use. Is it true?
Yes, please.
Yes. And then the slower you run, the more time you use. So this is a perfect example of real life situation involving indirect variation. As one quantity increases fast, the other reduces in terms of time. The other reduces in terms of time. Now, another example is when it comes to fuel. Let us, because it's something which is inevitable. When it comes to fuel, the faster the car runs, the lesser fuel it uses. I don't know if you've experienced it. I know most of you don't drive, but if you ask your parents, they can tell you more about it. That is why I don't know if you've observed this Uber drivers, um, when it happens that, or maybe let me use the taxi drivers, they don't like being in traffic because as you stay more in the traffic, the more fuel you use, right? And the more money you'll be spending. So in this case, they always want to go faster so that they don't use much fuel. Please, are you with me?
Yes, please.
All right. So that is direct one or the other example of indirect variation. So, or inverse variation. And as you rightly said, it is 1 over or it's a fraction of the first variable. It's a fraction of the first variable. So we write it in a fraction form. So when it comes to inverse variation, an increase in the value of one variable causes a corresponding decrease in the other value of the other variable, or vice versa. So when you have an indirect or inverse variation, this is how the graphical representation is. You need to know this. You need to know this. Please, are you with me? For instance, as the number of workers increases, the number of hours required for clearing a piece of land decreases. I don't know if you've experienced that one as well. So in school, you realize that when you have a piece of work and they want you to finish it in time, they would like to increase your numbers so that the time you use should rather reduce. But it is the other way around when it comes to reality. When right now we ask all of you to go onto a plot to go and then weed, this is where people will start chatting. So instead of using a lesser time to finish the work, they'll rather use more time. But in reality, that is not what is supposed to happen. We expect that you should use fewer hours to finish work when you are more in terms of numbers. So indirect variation, this is the graphical representation. As x increases, y decreases. So it becomes a curve. Or you can also draw it as this. You can also draw it as this. You can also draw it as this. As s increases, sorry, as s increases, because as you move towards the right, s values increases and y values decreases, so coming downwards. Therefore, the drawing will be like this. It will be a negative gradient kind of graph, or you can also draw it as a curve like this. So w varies inversely with h. That's a statement, and symbolically you can write it as w varies as 1 over h. And changing it into an equation, you must introduce the constant of variation, which is a k. So w varies as 1 on h, and introducing the constant of variation, w will be equal to k multiplying 1 out of h, and that will give you what is here. That will give you what is here. Please, are we all okay?
Yes, please.
All right. So let us take one work example on that. So suppose that y, let's write this down, please. Suppose that y is inversely y is inversely proportional to x. Suppose that y is inversely proportional to x and y is 0.4 when x is 2.5. Find a, the constant of variation, the constant of variation. B, the value of y, the value of y when x is equal to 4. C, the value of x when y is equal to 7. My people, are we all here?
Yes, please.
Good.
Please, I have a question to ask.
Yes, please, I'm listening. Go ahead.
Please, is it always that they will write in the question that the variables are inversely proportionate to each other or they are directly proportionate to each other? And
Yes.
if not, how do you identify?
Yeah, it's always that is a clue that you must always look out for in the question. And that's what you be able to use to determine whether the question is inverse or direct. So it always comes from the question. Always. It will be stated in the question. So you need to read it out and know which one to go for. Please, are we okay?
Yes, please. Thank
All
you.
right. You're welcome. So the way forward in solving this, then we need to change our statement into a symbolic form, or write a symbolic statement to represent whatever we have here. So suppose that y is inversely proportional to x. Then it means we have y varying inversely, so 1 out of x. And as I said, when you're able to write a symbolic form, you should be able to change it from the symbolic state into an equation. And changing it into an equation, that's when you introduce your constant of variation or constant of proportion. So we are going to have it as y is equal to k multiplying 1 out of x, which is the same as y is equal to k on x. Remember, this is for future um, investigations. Then going back to the question, they gave us a clue that in the future, when y is 0.4, x is what? 2.5. So this statement here automatically gives you a clue as to how to find your constant of variation. So you should have to go ahead and substitute into your equation to find your constant of variation. And that is, we're going for that to say that when y is equal to 0.4, x is equal to 2.5. Then we are going to have our equation as 0.4 must be equal to k on 2.5. So getting our k value, we multiply through by 2.5. So k will be equal to 0.4 multiplying 2.5. Please, what are you getting as an answer? Help me.
1.
You get 1, right? So it means our k value is equal to 1. K value is equal to 1. Therefore, our final equation is y is equal to 1 over x, because our k value is actually 1. Please, are you clear with how we've generated our final equation?
Yes, please.
All right. So since the question demanded for a, the constant of variation, which we've looked out for, k is equal to 1, going further to solve other questions like the value of y when x is 4, then we can do so. So finding y when x is 4, we are on b now. Y will be equal to 1 over 4. And 1 over 4 is a fraction, which you can reduce it into decimals. And therefore, what will be the decimal? 1 out of 4 in decimals. What is it?
0.25.
0.25. Good. You can leave your answer as 1 out of 4 or also write it in decimals. And it's accepted. But a warning is when it happens that it is it is a recurring decimal, then I'll advise that you leave it in a fraction form. For instance, if you have 1/3, and you convert 1/3 into decimals, it will give you 0.33333, which is a recurring decimal. So I wouldn't like you to write it as 0.33 or 0.333. It is best for you to leave the answer as 1 out of 3. But if it is a terminating decimal, then you can write it in fraction form or decimal form. So that is how we answer the B part of the question. Getting to C part of the question, the value of x when y is 7. So still having our equation as y equal to 1 out of x, making x a subject, you cross multiply, and it's going to be a switch, and that will give you x is equal to 1 out of y. So now we know our y value, so we can therefore find the x value, and that will be giving us x is equal to 1 out of 7. X equal to 1 out of 7. Or in decimals, what are you obtaining?
Please is recurring 0.142
So
8571429.
all right, thank you. So in other words, just leave the answer in the fraction form. Just leave the answer in the fraction form. Please, are we all clear?
Yes, please.
Okay. If that is cool, then now we can take 2 more work examples. I'm going to give one example on direct and the other on inverse or indirect. So let me put the question down all together, and then now we solve it. You are going to try your hands on them, then we all do it together. Good. Okay, so this is my question that I have. So number one, if P varies directly, if P varies directly as the product of the length L and the width W, and when P is equal to 80, L is equal to 15, and W is equal to 3. Find A, the constant of variation, B, an expression of P in terms of L and W, and then C, W, if P is equal to 120 and L is equal to 45. That's my first question. Number two, P varies inversely as scale. The table below shows the relationship between P and Q, or shows the relationship between the values of P and Q for some selected activity. So just that. So we have the table here. P is here, we have Q there. And we have 6, 8, 9, and 12. We have 24 here, and then we have 12 here. So we have this in the form of a table. Okay, so that's what we have. Now we have I. Let me write the question down here. The few space left. Find the relationship between P and Q. So find the relationship between P and Q. Find the relationship between P and Q. Then I find the value of the constant of proportionality. Value of constant of proportionality. Or in other words, constant of variation is the same. Constant of variation. Then final one is copy and complete the table. Copy and complete the table. Yeah, copy and complete the table. We have some few minutes left, but all the same, let us do the first one together. Then you try your hands on the second one and give me a feedback. I believe it's a fair deal, right?
Yes, please.
Okay, so let me copy the first one and then we'll move on to another screen. Do it together. You do the other ones. Yes, okay, here it is. Okay, so this is it. We're working this one together. And I believe it's easy. Now, interestingly, this kind of question also falls under another type of variation. But as long as this one has appeared here, let us do it together. And then when we move on to the other type of variation, we'll consider it also once again. Now, so P varies directly as a product of L and W. And I believe product means multiplication between two quantities. But symbolically, how do we represent this? P varies as a product of L and W. So L and W, they are multiplying. So this is the symbolic representation of the statement here, the word statement. Then we can change the symbolic statement into an equation. So changing it to an equation, yes, what would we obtain?
P
Changing
equals
P equals, yeah,
KLW.
P equals to KLW. Then now for future prediction, they give us a clue which can help us find K indirectly. When P is 80, L is 15, and W is 3. So P being 80, L being 15, W being 3. This clue can help us find the constant of variation. And that will be leading us to substitution. 80 is equal to K multiplying 15 multiplying 3. Are we all here?
Yes,
So
please.
80 will be giving us 15 times 3, an answer of what?
45.
45K. Therefore, K will be equal to 80 on 45. Break it down for me. K is what value?
16 on 9.
Pardon?
16 on 9.
16 on 9. 16 on 9. As I always say, either you leave it in a fraction, that's the perfect way. If it's when you change it to decimals and it will give you a non-terminating decimal or recurring decimal, please leave the answer in the fraction form. I'll beg of you. So we've gotten our K value. So that is the constant of variation. The A part of the question has been solved. So A, we have K equal to 16 on 9. Now it says write an expression for P in terms of L and W. That's a very interesting question. Writing an expression in terms of for P in terms of L and W, we wrote an expression early on, which was in terms of P, K, L, and W. So when the question demands that writing an expression for P in terms of L and W, then it means K must not be there. K must not be there. And in doing so, then our K value that we've had needs to be substituted. Then we get our answer. So the B part of the question, then we are going to have P is equal to 16 on 9 LW. And that is the expression we've written for P in terms of L and W. My people, is that clear?
Yes, sir.
All right. Then the last part of the question says we should find W if P is equal to 120 and L is equal to 45. And to answer that, since we've written an expression for P in terms of L and W, we can make W the subject and then we can get our P and L value substituted to get the answer for W. That's what we can do. So for C, either you substitute directly before making W the subject, or you can maintain it, make W the subject before you substitute. Any of them, you get the same answer. So having P value given as 120, L as 45, getting our W, which we don't know, per substitution we'll have 120 equal to 16 on 9, then multiplying the L value, which is 45, multiplying W. So this is the first way you can do it. Substitute before making your W the subject, or make W the subject from the equation or the final expression you had before you do your substitution. Any of them, you get the answer right. Now 9 can go into 45 5 times. Then you have 16 times 5. What answer are you getting? 120 is equal to
80.
16 times 5, then W. What answer did you say?
80.
80. So we have it as 120 equal to 80 W. Divide both sides by 80. Divide both sides by 80. So W will be giving us what answer?
3 out of 2.
3 out of 2. 3 out of 2. My people, are we all okay?
Yes, please.
All right. All right. I'm so happy you've gotten the concept clear, and it's fun. Please trust me, it is not just for WASSCE, it is for life. These things that we are learning, calculations here and there, it is for life. It must be part of you. It must be part of you. Any question on what we've done so far?
No, please.
All right. I'm so privileged having you on the lesson. And as I said, I have the second part of the question is here, or the second question is here. Please try your hand on this question and give me a feedback. It's unfortunate our time is up. Thanks so much for joining the lesson, and thanks also for subscribing to the YouTube channel. I'm so much privileged and so happy for you doing me the honor watching the videos and also subscribing to the channel. Keep on supporting me, and God richly bless you. Have a nice day. Bye bye.